We only see black holes in movies, right? They are, in fact, real and gigantic supermassive black holes. Of course, scientists have known about black holes for decades, but they have never been able to locate one until today. NASA scientists believe they have discovered one of the universe's earliest black holes thanks to the Hubble Telescope, which is 32 years old. So, what can we learn about our galaxy and universe from this black hole? In today's video, we'll go over all of this and more, so make a point of staying. It's necessary to understand what black holes are in order to appreciate why this discovery is significant. A black hole is essentially a point in space where gravity is so strong that light and matter are drawn in its direction. A black hole's gravity is so powerful that light cannot escape. A big star collapsing on itself and exploding in a supernova is the most common cause of black holes. A supernova is simply a star that has exploded. Galaxies and stars form at the same time as black holes as a result of this explosion. As previously stated, light and matter cannot escape a black hole. Because black holes are absolutely dark, they cannot be seen, hence the name. This is why scientists have long suspected the existence of black holes, but have never been able to observe one. NASA scientists have discovered what they believe to be one of the universe's earliest enormous black holes. They even gave this monster in the heart of our cosmos the name GNZ7Q, which isn't exactly creative. How are scientists able to detect GNZ7Q if black holes are invisible? Black holes, as previously indicated, are completely dark and therefore invisible. Special telescopes, on the other hand, have been developed to detect the presence of these black holes. Quasars are what these telescopes are looking for. A quasar is a very brilliant object in space believed to have created less than 1 billion years after the Big Bang by scientists. Quasars are generated when a supermassive black hole draws enough material from the surrounding environment into its center over a few 100 million years. Friction and other gravitational forces heat the substance till it transforms to energy. Only young galaxies and merging galaxies have enough material to generate a quasar for the black hole. Scientists discovered this gigantic black hole by discovering the GNZ7Q quasar, which is nearly 1 billion years old. GNZ7Q is 750 million years younger than the Big Bang, according to them. To put it another way, GNZ7Q is over 15 billion years old. GNZ7Q behaves in an unusual way compared to other quasars. The majority of quasars are extremely bright, whereas GNZ7Q is the polar opposite. It emits modest X-rays, which is likely one of the reasons it hasn't been discovered yet. Scientists have long predicted the existence of old low-light quasars, such as GNZ7Q, but have yet to discover one. It may come as a surprise to hear that the location where GNZ7Q was discovered is well known, and scientists have made numerous astronomical measurements there in the past without finding a quasar. What's the big deal with GNZ7Q in the first place? Because GNZ7Q has the potential to solve a significant portion of the puzzle surrounding the origin of our universe. Scientists have long assumed that the first galaxies began to combine at the beginning of our universe, and the gas within them squeezed into new stars. These stars exploded because they were born at the same time that other stars were dying. The supernova explosions would agitate neighboring gases, which would eventually fall into the galaxy's black hole. Scientists believe that this process has a number of effects on galaxies. It provides them with enough matter to transform their center black hole into a supermassive black hole. Such to the one pointed out by GNZ7Q, it protects galaxies from dust and creates the ideal environment for quasars like GNZ7Q to emerge. There was no way to prove this notion for a long time. Thankfully, GNZ7Q has arrived, and scientists may now use it to further their knowledge of black holes. According to NASA's Jennifer Wiseman, GNZ7Q is not yet a complete quasar. The object has not yet turned on, or we can't perceive it as a quasar. She said in an interview with CBS News, but it's kind of intermediate. Some of it indicates that stars are still growing at a rapid rate, and that debris is beginning to tumble into the core of this early galaxy. We can tell that this object is somewhere between the earliest galaxies and the earlier quasars in the core by looking at multiple wavelengths of light. This is an intermediate level. She also explains why NASA has taken so long to discover GNZ7Q. The deep universe has provided us with some spectacular images. These are galaxies' fields. Some of these galaxies shine brightly on us from a great distance. The light has taken a long time to reach us. One of the previously missed red spots in one of these galaxy fields turns out to be an emission from a very distant galaxy, glowing just 750 million years after the Big Bang, the beginning of the universe. That was quite some time ago. However, we must remember that these fascinating discoveries would not have been conceivable without the Hubble Telescope. The Hubble Space Telescope, which was launched in 1990, continues to impact our understanding of the cosmos. It happened with the discovery of GNZ7Q2. Many scientists are more enthusiastic about finding black holes now that they know there could be additional supermassive black holes like GNZ7Q, thanks to the fact that we now have super telescopes, like the James Webb Space Telescope, which was recently launched. If you enjoy this video, please show us some love by liking and subscribing to our channel.